This free and open source game engine allows you to create games easier and quicker than ever. But how quick exactly? Can I finish creating a game in just 8 hours, starting at 4 PM and finishing just before midnight? My name is Gelef, and this is Shift, a casual platformer about shifting different terrain layers to reach your goal. But first, what exactly is Shift? In Shift, you're playing this handsome lad who can freeze time while moving count them, two different terrain layers to reach his goal. What exactly is this goal? This glowing orb of light, of course. But let's put lore and story aside for now. After drawing our character and changing Godot's display settings to make him appear extra crisp, it is time for actual code. Normally I would probably just let the character body 2D handle all the inputs, but since we will soon control the terrain as well, I decided to only handle physics, sprites and state changes inside the character and move input handling to a dedicated character controller. Most important here is the active boolean, which will later be renamed to isFrozen, just for clarification, which controls whether physics and states even get calculated. Inputs themselves are bound using Godot's built-in input map, where binding custom actions to keys is made extra easy. For now, we just get an input axis and multiply it with our maximum walking speed, and use the lerp function to smoothly change our speed. I can say from what little Godot experience I have, that this just feels a lot nicer. Especially after fiddling around with some numbers to make the movement a bit less floaty. Jumping, on the other hand, should be instantaneous. And while we didn't add things like a variable jump height or coyote time in the mix, it felt enough for the type of game this is. Then it was time to start the first tests. For now, just a mostly empty level with a mesh instance to simulate our terrain. This was also the moment I realized that mesh instances actually scale all their children, which makes adding collision even easier. And just as expected, the game runs. Well, it starts. Here begin all the little things I tend to mess up in the beginning of a project. Like mixing up vertically and horizontally, or not adding gravity. And then having everything be way too floaty. But this at least was expected, and after some fiddling, the character's fast enough and responsive. Next it was time for actual terrain. Yes, I could use the placeholder for everything, but the earlier I use proper systems, the earlier I can find out if they actually feel nice to use. For the terrain, I just wanted to use a tile map. Especially because I heard that there's Godot's terrain system, basically the connected textures, which would make modeling levels extremely easy. So I went back to Krita and made a 4x4 grid of 32 by 32 pixel squares and started drawing some basic shapes. Since I knew I wanted to use different colors for the different layers to differentiate them, I thought I would just model the whole terrain in white and modulate the color inside Godot. For the terrain to work, I would need one sprite block per possible connection, I think at least. But I feel like there should be an easier way to rotate sprites inside the engine itself, but instead of finding out, I just spent the extra minute or two just manually drawing all rotations. Now I could add the tile map to the level scene. Just add the node and create a new tile set in the inspector before adding the texture under the tile set tab. I didn't use a standard tile size of 16 by 16 pixels, which led to me having to fiddle around with the tile map as well. Tile maps are somewhat weird in this Godot version. If you change the tile size and some of the automatically created tiles move outside the atlas, you can't just remove them and get tons of error messages if you try to start the game. So I would just recommend to do them manually, especially if your atlas isn't all too massive. Now to the interesting part, actually creating a terrain map. First we create a terrain set inside the inspector and add a terrain element inside of that one. Name and color are not that interesting here since we only use one layer, but it would make mixing and matching different terrain options easier. Then we go into the tile map again and paint the terrain property, selecting all our tiles and then selecting all the edges where our tiles should connect. And with some playing around I managed to get it to work. And since I will definitely not have to remap the whole terrain another 10 times, this will be about as good as it's going to get. I figured that the terrain was still missing some options, so added some endpoints to the atlas, which improved the responsiveness when drawing the terrain immensely. And now it was time to add collision. Just add the collision layer and painstakingly paint boxes on every single tile. But don't worry, I learned from my mistakes and find out how to massively streamline the process. Later at least. And with all this done, I can finally test the whole thing. And I forgot to remove the background in my terrain atlas when adding the ending bits. And also the collision is kinda wonky. Seems to be because I didn't perfectly align with the hitboxes, but for now at least it's working. So it only took about an hour to reach this point. A character with basic movement and some white lines. Now blue after modulating it. But this is a good starting point and I feel like I make great time. Now it is time to add the layer functionality. You know, the thing that's going to make this game slightly more interesting than the average tutorial platformer. For now I'm just adding some attributes for the layers inside the player controller, as well as the unhandled input function to check for the player's mouse movement. Now we can just add some basic input handling and some setup functions for the character's isFrozen attribute. And we can basically copy paste the code for a second layer, which is nice. And who could have seen this coming? Pressing some random buttons led to me breaking the tile maps and having to remap them completely. But this at least gave me the chance to add another tile for tiles on the lonesome. This is also the point where I realized that I could just enable the grid, which made remapping the collisions so much easier and cleaner. And this time I would actually save the tile map for later reuse. Now I could easily create level geometry. While this took about half an hour, it would probably save me a good hour or two later down the line. With all this, I now had all the basic mechanics in place. Not that there were that many to begin with. While I still had some plans for other smaller mechanics, the deadline really deterred me from starting the feature creep. I finished hour 2 by adding placeholder code to switch to the next level and to reset the level. This took way longer than I wanted, thanks to me being way too lazy to properly read an error message. The next level is a packed scene, saved in an exported variable. All the objects which needed to be reset were just added to an exported array of node paths. The reset function itself would just call every individual reset function of objects inside the array. To get this to work, I needed to add an additional script to the layers, which basically just saved the starting position on load, and I added similar functionality to the player character. Just make sure to use the getNode function with the node paths and check that the array is actually fully filled with correct values, and you can save yourself about 15 minutes of your own time. The switched scenes I luckily just needed to pass the packed scene, meaning the scene file, to the correct function. Now it was time for the level's goal. This time, instead of starting with a static sprite, I decided to directly create an animated sprite. The goal doesn't have that much functionality, so it would feel nice to finish something completely, or at least to bring it into the MVP state. Similar to the terrain, I created a larger file big enough for 5 frames and added some shapes with some imaginary glitter. I decided to use a white brush again and to modulate the color inside Godot later on. The gate itself would just be an animated sprite to denote. Then I could just create a new animation and fill it with all the frames. The animation player even allows you to set the frame rate and to keep the sprite animating constantly. The script itself was also quite easy. The gate only needs to know about the level controller and call it once the player enters the collision radius. And the check is even easier, since we already named the character class. The next task was one that gave me a lot more trouble than it should have. Currently, when you unfreeze time while inside the terrain, you just pop out one direction. Instead, you should lose. This basic mechanic will be a lot more interesting in later worlds, where I might use a tileset with denser terrain, but for now it's just here to add a little bit of challenge. And I tried for a long time, and I just couldn't get it to work. I tried getting a signal, and I tried just getting overlapping areas of a special depth area, which would be smaller than the character's hitbox. But whatever I did, I just couldn't get the overlapping bodies. And this was how I spent most of my third development hour. The first solution that worked was to shrink the character's hitbox while he is frozen and regrowing it a frame after unfreezing him, thinking it might have to do with the hitbox overlap. Spoiler, that wasn't it, but it worked for now. Now that the temporary depth detection was in place, it was finally time to breathe some life into our protagonists by giving them their own animated sprite. Unlike the gate, the character would need multiple animations, which can all be added via the sprite frame tab. I just had to make sure to only play the depth animation once instead of calling it every frame. Continuing with some cleanup and polish, next would be the main menu. Godot uses so-called control nodes for anything related to UI. And I have to admit, I previously thought they were a bit confusing, but once you play around with them for a bit, you get used to a lot of their oddities. One important thing is to set the layout mode to anchor instead of position, which allows for a way easier workflow. It is just weird that some nodes seem to not allow you to change the setting. In that case, you just need to put the element in its own dedicated container. Playing around with it for a bit, I ended up with this basic layout. I wanted to add some more color to the project, so I settled on a basic sky backdrop. Just add some gradients to a full HD image, blue and pinkish until it looks like a sky. And then I took out a fancy brush to add some clouds. Since I wanted the background to slowly move, I switched over to Krita's wraparound mode, which is generally great for creating repeating tiles. Then it was time to implement the whole thing. I created a canvas layer as its own scene and added an image as a sprite onto it. And while I knew it was possible to create a scroll effect using parallax layers, I decided instead to create a new shader material for the sprite. Shader materials have scripts, which basically get called for every visible pixel to calculate the color in a certain spot. This script sets the pixel color of the corresponding pixel of the texture, but adds time to it. But this still doesn't have the wraparound in it, and we can't just use a basic modulo operator since we are working with floating point values, so I had to code my own implementation in 2 lines. Since the texture coordinate is just a value between 0 and 1, both for x and y, I could just take our previous value and subtract the integer value right beneath it. To automatically add the background to each level, I used Godot's autoload functionality. To finish up cleanup, it was now time to add music and sound effects. After downloading some great sounds, I could just create an audio stream player with the background music as its own scene and autoload it. The character also got his own 2 audio players for jump and death sounds. These ones use the 2D audio players though. Now that the game looks a bit nicer, it is time to finish the menu. I just used some simple labels and then used the theme overrides to create a black outline. Instead of switching scenes constantly, the menu consists out of multiple control boxes, which can be hidden and unhidden by pressing a button. This way every single button has to be manually assigned, but it's fine since there are only a few anyway. This is also where I start working on the level select. There's a convenient control node called grid container, where you can just declare the number of columns and the rest gets aligned automatically. Instead of dummy buttons, I wanted to dynamically create buttons with some functionality. So I created a scene consisting out of a single button and added a simple script with a button up signal and added a setup function. Every button will know the path to a level scene file and will be able to switch to that scene if pressed. To create the buttons, the grid container from earlier gets a script where it loads all the files via a dir access class. The load script is basically the one from the Godot documentation, but instead of printing debug messages, we instantiate one of the button scenes for every file in the designated folder before adding it to the control node. Obviously, you shouldn't forget to read the next file name at the end of the loop, otherwise you will just hardlock your game. To finish the level select, we now only need to find out which levels can be selected. For that I created an autoload node similar to the background music one. This one just saves the value of the highest beaten level number, and levels with a higher number than intended don't even get loaded in the level select screen. We can just get the current scene's name with a standard function, so by just naming the levels with a number, we can find out the level number without any extra work. After adding a way to return to the main menu, I was basically done, so I thought at least, outside of actual level creation. To make the whole process easier, I created a scene which I would later use as a template for every level. The advantage in that is that whenever I would have to make a change, I could instantly affect every level I had created. The level template had basically all the nodes the test levels had. 2 layers to move, a character and controller, the camera, and a main node with the attached level controller script. By selecting new inherited scene, we could instantly create a prepared scene to work with. The nodes in yellow are the ones inherited by the template and will change whenever I make changes to the template. During level creation I noticed 2 things. First, it was really easy to cheese levels, since you could always just freeze time and move platforms in the ideal position. Had I wanted that, I could have just added a freeze button instead of unfreezing when letting go of the mouse button. So I added a condition that you can only freeze the character once after he leaves the floor. The second thing was a feature I had forgotten. In addition to terrain, I wanted to create barriers which would always kill you, even if you were frozen. Originally I wanted to make a copy of the tile map and add a kill property to it, but doing so broke the tile map again, so I had to remap everything once more. And this time twice. The kill property was just the tile map again, with the same collision shape, but I set the collision layer to 3, so you can just fall through it, and I also added a death group to every death layer I would add to the level template. The death group later just makes checks easier. But working on this at least gave me some time to think about how collisions in Godot work, and I came to a realization. The reason why my death collision after unfreezing was so wonky was simply because of how the collision is handled. The following is more my theory, which appears to be correct, more than actually looking deeper into it. Tile maps are static, and by that I mean they never actually check for collisions themselves. I mean, why should they? You would assume that terrain doesn't actually move. So instead, objects moving into the terrain have to do the collision check. And realizing that, I was able to not only make the dev planes work, I could also improve on previous code. Well, somewhat improve at least. I feel my solution is far from the best, but time was slowly running out, so I went with it. I changed it that while the character is frozen, I would temporarily set its velocity to 0 before moving it 0 units and then putting the velocity back to what it was before. It doesn't seem that clean, but it works and lets me remove the weird hitbox rescaling I used before. And now that the last hour had started, I could finally work on level design. And for this mini project, I wanted to make 5 levels. Obviously, I got some errors while designing, most of which came from me not properly linking scenes, but that is why you test whenever you add something new. But there was now one last thing I had to do. Most games I play start way too loud. This is especially true for web-based games, which tend to not include volume options. And when you use your browser for multiple things at once, changing the volume in the audio mixer is just really annoying. So this is why I added a volume slider as my last feature. And it was actually really simple. There already is a slider node in Godot, and now I only needed to give its value to the main audio stream. Which was really easy, and now I didn't even have to change the audio players. Also another thing that annoys me about basically every game I play, why is the default audio volume the max volume? It is so much nicer to have a lower setting and manually increasing it when needed. But that might just be a me issue. For now at least, I just made it so that the slider would change the audio bus volume between 0 and negative 80 decibels. And now I was actually done. A project in just about 8 hours of work time. I would count it as a success. At least in the sense that I made a playable project in 8 hours. But I have to admit, it didn't all turn out as I wanted. There were actually a few things wrong with the project and the way I work I only noticed while going through my recordings. For example, I always thought I was a decently fast programmer. At least it always felt that way back when I was still working with other developers in my old office. But looking over the footage I always felt as if I was waiting around in the middle of a function name. But there's actually more serious critique to be made. For one, I forgot to loop the music. Something I instantly noticed when I looked at the gameplay clip, but I completely ignored while testing. Next problem is the level design. There are two main issues I see with it. First, basically all levels can be cheesed if I put the goal on one of the movable layers. So I probably shouldn't do that in most cases. Second, you can actually optimize the fun out of the game quite easily. Currently, you are only allowed to freeze time once until you reach the ground, but nothing stops you from switching layers while jumping. So you in theory can move one layer back and forth while pulling the second layer in one direction. And lastly, the project didn't actually work as an HTML game as intended. Luckily this only had to do with the way I was loading the different levels, as, for some reason, files are renamed when the game is exported. To fix this, I only had to remove the .remap suffix and the game was working again. While I might sound quite negative about the game, and most of this might just be me being cynical, I am actually quite happy about the project. The 8-hour time limit feels like a decent amount of time to develop an idea, if you have made some plans for it beforehand, while still giving you enough time to experiment when something doesn't work as expected. I would definitely recommend everyone who struggles with finishing projects or just over-planning them to try this challenge. In these few hours, and many more editing, I not only created a playable game, which, when tweaked slightly, I would actually want to play. I also learned about things like tile maps, terrain, collisions, autoload, and audio players, as well as getting a feel for how UI elements work. Funnily enough, editing actually took so long that I participated in a game jam in between, which limited development time to 3 hours. So the whole premise of this video now kind of feels lame. Anyway, if you want to test out this game for yourself, visit my itch.io page down in the description. And if you have tried such a challenge yourself, let me know in the comments. I'd love to hear about it. Next video will be something that won't take me 2 weeks to edit. So with all this, there's only one thing left to say. Lullaby.